In 2022, humanity launched its most ambitious window into the cosmos, the James Webb Space Telescope. Hovering 1,000,000 miles from Earth, it stares into the deepest recesses of space and time, and what it saw defied everything we thought we knew. The telescope revealed something unexpected, fully formed. Massive galaxies existing just 300 to 400 million years after the Big Bang, a time when the universe should have been too young. It's too chaotic and too hot to form such structures. These galaxies appear too old, too evolved, far too massive for their age. They're not just cosmic infants, they're galactic adults in the toddler years of the universe. And that single discovery could append the standard model of cosmology, possibly rewriting the history of everything. In the Lambda cold dark matter model, our current best theory of how the universe evolved, galaxies form gradually, in less than 400 million years. That's not just fast, it's almost physically impossible by current models. First, the Big Bang creates a hot soup of particles. Then, as the universe expands and cools, matter starts to clump under gravity, forming the first stars and proto-galaxies over hundreds of millions of years. But JWST discovered galaxies like Galaxies SZ13, which seem to have already assembled billions of solar masses worth of stars. It's not just one galaxy. Spectroscopic data confirms their redshifts. Their light is real, their structure confirmed. These galaxies are that old and that evolved. Simulations that match these JWST observations require star formation rates hundreds of times faster than what is typically observed. With extremely efficient gas cooling and clustering mechanisms that remain hypothetical at best, dozens of them, all massive and well-structured, are appearing where none were expected. Perhaps dark matter condensed into halos earlier and more densely than expected. This would have created gravitational wells deep enough to collect matter quickly, accelerating the birth of galaxies. The stellar densities, metallicities, and light profiles suggest a level of maturity that should not yet exist. These aren't just theoretical anomalies. These are observational facts. It may have created far more structure than we assumed, seeding early overdensities that jump-started galaxy formation. If fundamental constants evolved over time, the early universe could have formed galaxies faster, condensed matter more efficiently, or even warped time itself. Perhaps early gas clouds were far denser, more efficient, and cooler, allowing them to collapse into stars at record speeds. This suggests one of two things. Either our models of how galaxies grow are wrong, or our understanding of the early universe is missing something massive. How could galaxies grow so large, so fast? They could have merged rapidly, shaping galaxies in mere hundreds of millions of years instead of billions. It's gone more rapidly than previously thought, igniting intense stellar feedback that altered their galaxies within a few million years. One theory proposes that we're underestimating the rate of early star formation. But even with optimistic assumptions, the math doesn't check out. Another idea is that we've misunderstood the dark matter scaffolding that underpins galaxy formation. From the moment of the Big Bang to the formation of galaxies, stars, and maybe even life itself. Still, these explanations require tweaking the laws of physics as we understand them. And that opens the door to even more radical possibilities. If the standard cosmological model can't explain what we see, we must consider alternatives. One possibility: cosmic inflation, the rapid expansion of the universe moments after the Big Bang, may have behaved differently. Another radical idea: the speed of light or gravitational constants may not have been fixed in the early universe. Then there's the speculative realm, simulation theory. Some suggest that JWST results are so contradictory to expectations that they resemble artifacts, like rendering errors in a simulation. It's unlikely, but it illustrates how mysterious and disruptive these observations truly are. In short, we might be witnessing the universe revealing cracks in the model we've trusted for decades. If these early galaxies truly exist, and there's no error in the observations, then our entire cosmic timeline shifts. Dark matter might have formed earlier, gravity may have been stronger. Star formation could have occurred in environments fundamentally different from what we thought was possible. Even more profoundly, these discoveries may mean the first black holes. Perhaps seeds for the supermassive ones we see today formed much earlier. Some models now suggest population 3 stars. The very first stars ever formed might have come the early universe wasn't a slow, gentle emergence of structure. It may have been a cosmic storm, building vast architecture at lightning speed. The James Webb Space Telescope didn't just extend our vision deeper into the past. It opened a crack in the universe's story, revealing that perhaps we don't know the first chapters at all. As more data pours in, as new observations confirm or challenge these findings, we may be on the verge of rewriting everything. The cosmos has always been mysterious, but now, more than ever, we are reminded that every answer leads to bigger questions, and that the universe is far stranger and more beautiful than we ever dared imagine.